Right, good evening, everybody, and you're all very welcome to this very special edition of the Van Mildert College Dimensions program. I guess unless you've been living on another planet for the last couple of months, you'll all be aware of the fantastic work that Steve Lindsay, our speaker tonight, has been doing with his colleagues from the London School of Hygiene and Tropical Medicine. I was going to say a warm welcome to Steve, but in fact it's a welcome back to Steve, because I remember I'd only been here a couple of years and Steve held his, I think it actually was his second inaugural lecture at Durham University, and it was a really amazing lecture for me and the audience there. Steve talked about malaria control, success and crises. He talked about the fantastic work his group was doing on insecticidal bed nets, indoor residual spraying, all these sorts of mechanisms to essentially cut down malaria and its spread. And this research is, of course, of immense benefit to mankind. Well, we're going to return to something that potentially has immense benefit for ourselves. It's groundbreaking research. It could change the course of the history of this particular pandemic. And I'm going to turn over to Luca, who's now going to give a more focused introduction. But thank you again, Steve, for doing this. And I'm really looking forward to it.
Thank you, Dave. And thank you as well to Steve as well. And we're really looking forward to this event. I'm just going to start with a little bio from Steve. So just to give you guys a bit of an introduction to who he is and how he's got to the position that he's in. So Professor Steve Lindsay is an expert in diseases like malaria and dengue, which are transmitted by mosquitoes. His first degree was in applied zoology at the University of Bangor, and he completed his PhD at the London School of Hygiene and Tropical Medicine. Over the last 35 years, he has carried out medical research in many countries in sub-Saharan Africa and Southeast Asia. He has written over 260 scientific papers and co-wrote the World Health Organization's strategy on the control of insect-transmitted diseases. He has been in the Department of Biosciences now for 23 years. Steve is also a keen cyclist and represented Great Britain as an age group triathlete in 2 European championships. So I'm not going to spend too long kind of lingering before we move over to Steve, but I would just like to say, as kind of a formatting thing, if any of you want to kind of send through any questions at any point during the talk, Steve has been kind enough to be really open to questions. So don't hesitate sending those questions through. I'm not 100% sure how it will work, but if you can direct it just to me individually, or whether it's just putting it forward as a Q&A, that's fine. But I'm just thinking what's going to happen is I'll get through the questions during the talk, I'll bring them all together, and then we'll save some time right at the end after Steve's spoken, and we'll pose those to Steve, and he can obviously address those for us. So yeah, feel free to send questions throughout the talk, or alternatively, you can save them through to the end. But yeah, Steve will be happy to answer them. So no, thank you so much for joining us, and I'll now hand over to Steve.
Thank you very much, Luke and Dave, and good evening, everyone that's watching this. And a special congratulations to all the undergraduates that have finished their exams for the moment, or finally. So well done. At least you can enjoy the beautiful weather that we're having here in Durham at the moment. So the talk I'm going to give you tonight has been well advertised. It's about dogs and COVID, but I'm going to extend it beyond that. But I want to start by making very clear that this is not just me. In fact, I'm a small bit player really in this. This has been led by James Logan at the London School of Hygiene and Tropical Medicine. And all the wonderful, exciting stuff with the dogs has been done by Claire Guest, who's the director of a charity called Medical Detection Dogs. And it's been an absolute joy working with my 2 friends over not just the past year, but for the previous 2 or 3 years. So let me see if I can get this to move forward. Oh, it's okay with the click. So first thing is that some infections or some diseases result in particular smells. So this can happen from an early stage in infection with a disease. So to give you an example, typhoid smells of bread, or TB, tuberculosis, can smell of beer, and yellow fever smells of meat. And we have heard anecdotally from a GP that COVID actually smells of a mortuary, which sounds deeply unpleasant. But can be a rationale behind this, because with diseases like malaria, which is transmitted by mosquitoes, it's acting as a signal to mosquitoes to come and feed. And it seems that with malaria, anyhow, people that mosquitoes can feed preferentially on people that have the malaria infection in them. So there's a lot going on here. But so we associated particular diseases with particular smells. This has been used by medical profession for hundreds of years. And just to give you an example, this is an ancient instructor's guide, if you like, to diseases by examining the urine. So this beautiful Technicolor wheel illustrates different colors of urine associated with particular infections. So a physician of the past, in the 16th century, could have a crack at diagnosing a patient with a particular illness by not only the color, but the smell and disgustingly taste. So I hope that doesn't put you off your supper. And this was used to diagnose the disease, and it continues to the present day. So there's always been an association between smell and particular diseases. Now, I used to give a module on changing patterns of health through the ages, and I used to show my students this particular image of Saint Roch, who's the patron saint of the plague. Now, he was around in Europe during the first major outbreak of plague in Europe. And if you look at this image, you'll see that Saint Roch is pointing to a lesion which is in his groin. Now, this is an inguinal node which is infected with the bacilli of plague. Plague is a bacteria transmitted by fleas or by coughing and spluttering. Now, the reason Saint Roch was a saint, main reason for being a saint, was that he treated those that were sick with plague and never got the infection. Now, what's interesting about his inguinal node is it's cleanly cut and it's nice and clean. Now, this is what a infected plague inguinal node looks like. This is a bubo in the terminology of plague, which is full of pus, not very nice. So Saint Roch somehow managed to not suffer the effects of the plague. Now, that was all very well, and some months ago, I was telling my colleagues about, surely you know about Saint Roch, very famous chap, and I looked on Google to find some images, and here are some of the images. And what you can see here in the bottom left-hand corner of the one picture on the left is Saint Roch with a dog. There in the center is the dog, and there on the right is a dog with what it looks like remnants of a hamburger. And there again you have the image of the saint pointing at a lesion, which is not where the inguinal is, but artistic license. We'll let them get away with that one. So why the dog? So when you look into why the Saint Roch got his sainthood, was because the dog cleaned out the wounds and brought him bread, so he survived. So that sounds curious, but there have been many other anecdotes about dogs identifying particular ill health on people. So, for example, my friend Claire Guest, who's the director of the medical detection dogs, actually had breast cancer, and she was alerted to the breast cancer by her dog being agitated and scratching at her. And that prompted her to go to the GP, and she later found out that she had early stages of breast cancer, which was curious. So the thing about the dog is that this is an extraordinary animal. And I know you've got dogs at home which are pretty useless and won't come when they're called or won't sit when they're shouted at. But the dog has an extraordinary ability that we barely really understand. Now, if you look at this cutout on the top right, there's a section for the dog's nose. And the green bits represent the olfactory system, which is just packed full of cells which detect scent, each one individually. 300 million of them in a dog, compared to ours, which are a mere 5 million. But actually, human beings are pretty good at detecting scents. And what I think is really interesting as a biologist is that these olfactory cells are sort of more or less unchanged through the animal kingdom. And the ones we get in dogs are the ones we have in humans, not surprising because we're mammals, but they're the same in mosquitoes as well, which is a radically different creature. So it's a neat system, but the dog has lots. And it's able to detect at extraordinary low concentrations of 1.5 per trillion, a particular element, which is equivalent to taking a teaspoon of sugar and immersing it in 2 Olympic-sized swimming pools of water. That's what a dog can detect. So an Olympic-sized swimming pool is 50 meters and pretty deep as well. So that's a lot of water. That's a huge dilution effect. So the dog has an extraordinary sense of smell. So we call them medical detectives, and highly trained, they can be used to detect all sorts of ailments. So from levels of sugar, for cancers, malaria, Parkinson's. And so this has been the work of the medical detection dogs up till now. They've trained the dogs to identify different types of cancer, prostate cancer, bladder cancer. And they have alert dogs as well, which alert dogs to whether someone if they're a diabetic and they're not sure, if they can't control their glucose levels, then the dog senses whether they're too much sugar or too little sugar. And I think one of the first medical detection dogs was a professor of physics at Durham University. So there's a Durham connection to that as well, which I find it interesting. So what I'm going to do is tell you about my introduction to Claire Guest and the dogs and working with James Logan, because my area of expertise is, as Dave said earlier and Lucas spelled out as well, is malaria. Now, malaria is a disease caused by a pathogen which lives in red blood cells amongst other cells. And in this photo, you can see here that the red balloons of red blood cells and the yellow balls inside are the malaria parasite. And that's where we joined up, the three of us, because we thought, well, okay, so you've shown that the dogs can manage diabetic patients, they can detect cancers. What about malaria? Could we use the dog to train to identify people with malaria who weren't sick? I think that's important. So that may seem a bit of a contradiction to you. And you say, well, malaria is really very serious, isn't it? And it kills people and makes them sick, which it does. But you can also develop an immunity after numerous attacks. And so you can have children that carry the malaria parasite and running around literally playing football, who are not sick with the disease. And these people, innocently enough, are carrying the parasite around they can get bitten by more mosquitoes and transmission of the disease carries on. So we set out to address whether dogs could identify malaria in people by the smell. And so we went to the Gambia, which is a place I've worked for the last 35 years. And we went to the far end of the country where they have the biggest problem with malaria. And we went and visited several schools at the end of the rainy season. And these photographs, you see the children in the schools. And what we did was gave them all these really lovely stockings. They're short nylon socks, in essence. And we asked them to wear them overnight. And the following day, we collect the socks, we wrap them up in aluminium foil, send them away to the freezer, ship them back to the UK. And what we then do is, well, the morning after we've taken the samples is finger prick the children, look for malaria parasites. And we then identify those children that are positive for malaria and those that are negative. And then we train our dogs. And the training is a long process. It starts in the beginning with either playing with the dogs or giving the dogs a treat, depending on the personality of the dogs. If you've got a Labrador, they'll do anything for a small bit of food. But if you've got a Cocker Spaniel or Springer, they'll probably prefer to play with a ball. So this is the training and testing setup that we use. And what you can see is 4 stands in the center. And in the each one of those stands would hold a small piece of sock that's been in a freezer for 6 to 8 months, taken out, brought up to room temperature and put into a little glass bottle in each of those stands. And the dog goes down the stands. And when it comes to a positive sample, it either freezes and stands and often wags its tail, that's indicating, or it can sit down depending on the animal. Behind the screen is the handler. And the handler is behind a screen, so the dog can't get any visual indications from the handler. So it's acting alone. And when the dog indicates, the handler calls out, it's a number which would be a positive number. And the person ringed on the right here is an experimenter, a technician that will enter that code. And as soon as that code is entered, he or she will see whether the dog was correct or not. And if the dog is correct, then it's rewarded. So we've got 2 arrangements here, and this is a bit cunning, and it tells you something about the psychology of the dog. We either have 3 negative samples and 1 positive, or 4 negatives. Now, that's really important to have the 4 negatives, that the dog goes along and doesn't indicate. Why? Because if you always have the situation of there's always a positive there, then the dog is not remembering the smell of the disease. It's remembering, or it's recognizing the odd one out, which is not what we want it to do. We want it to detect from all the background smells, because we all smell different, people of different ethnicities, different ages, different genders, whatever, we all smell slightly different. So the dog's part of the training exercise is to filter out that background and to identify the distinct smell associated with that disease. So let me just move things around and show you what it actually looks like in practice. There we go. There we've got the trainer. The dog goes, there are 4 stands. The dog's indicating, standing and waving its tail. So the handler called out, number 4, it's correct, the dog gets rewarded. That's all very fast. So I'm going to show it to you again from a different angle. No. Wait a minute. It's very clear that this is the malaria case, how quickly the dogs put this up. So what did we find? The dog's pretty good at this. So we have overall with these dogs a sensitivity of 81% and a specificity of 92%. What the hell does that mean? So 81 sensitivity is how good is the dog at identifying positive. So what this means is if you had 100 positive samples, it would detect 81 of them. Specificity is the reverse. It's how often does it make a mistake, if you like. So if you had 100 negatives, it would make 8 mistakes, if you like. It would get 92 negatives right, it wouldn't indicate, but there would be 8 where it would get confused. Now, interesting in this study, we think that the dogs weren't confused with the specificity, with that they were actually indicating children that were actually, although they were children when the child was negative, they were sleeping in beds with positive children. So they may have been picking up a child that was uninfected with malaria may have been picking up the malaria smell from a child in the same bed. Hey, never work with children and animals, hey? So, but it was a really important case. And what we're trying to do now is with malaria is to use dogs at ports of entry. So places like South Africa, which are trying to eliminate malaria, have problems with travelers innocently coming in from Mozambique, which has a lot of malaria at the borders. And what we'd like to do is use our dogs at the borders to rapidly identify people coming into the country with malaria so we can treat them there and they can go on their way. Okay, so that's our background. So now you can see where we were at the start of the pandemic. So it was quite a logical step to say, well, how can we help? As a biologist, we've got this huge threat now of COVID-19. We're all a bit frightened. We don't know what's going on. We don't know how lethal this virus is, but we're not surprised that it's happening. I was talking about this 13 years ago to my students that we were going to get a major pandemic, so I was not surprised. So what did we do in biosciences? Well, the first thing we did was went and helped hospitals and gave them PCR kits, and a lot of people from biosciences went and gave their time free to the NHS to do PCR diagnoses for COVID. Once that was out of the way, it was obvious then we should ask the question, well, dogs can identify malaria from their scent. Do you think they could do it with COVID? And we're starting with a blank sheet of paper. We know nothing. Is there a COVID smell? Can the dogs identify this? So what are we doing now with our testing? Well, I presume everyone that's watching tonight will have had a COVID test of one sort or other. Lateral flow test, up the nose and the back of the throat. It's labor intensive, it's invasive, and it's slow, and it's not totally accurate. In the early days, people were measuring temperature, but you're only picking up people that are sick. And we know that, like in malaria, that there's a large number of people that are infected, but they're not sick, and they're just carrying it around, probably transmitting the disease. So we thought, okay, a rapid tool for screening COVID would be really, really important. So we carried out what we described as a pilot study, which is a phase 1 study between London School, Durham, medical detection dogs, and Cardiff University that are pretty good at identifying the chemistry behind these volatiles that people produce. and 20 dogs in training. 20 dogs in training, 30 people working at the London school, and probably about 20 people working medical detection dogs. But this is what you want to see, isn't it? These are the real stars of the show. These are our dogs. Victoria asked me earlier, what sort of dogs? Well, they're all very beautiful dogs, but more than that, they are working breeds of dogs. Dogs which typically work with their sense of smell for finding out things. But you have to train these dogs to hone that skill. And I'll just point out, we've got Millie and Tyler and Marlowe, and down at the bottom, Kip and Asher are two rescue dogs as well. And Asher in particular is very good at what he does, and he's a working Cocker Spaniel with a bad hairdo, and I think he and I go to the same barbers. But so these are the dogs that were tested. And what we did was we worked in 24 NHS trusts and track and trace. You may have heard of some of our publicity. I noticed that down in Territorial Lane, there's still one of our signs up, which I must take down, asking for volunteers for this study. We got almost 4,000 volunteers to help us with this, because we needed to produce a large number of negatives and a large number of positive samples, because the more samples you have, positive samples, the better it is, the easier the dogs find it to filter out the background smell and identify the smell that we're really interested in, a COVID smell. So one of the things that makes our study special is that we use a training set of samples, negatives and positives, which were completely separate, came from separate individuals that we use for testing. So we trained on one set of samples, tested the dogs on another, that the dogs had never seen before. So that it's what we call double blind. The dogs have not experienced that, because dogs can remember smells. If you work with a small number of samples, they may just remember the ones they got the biscuits for. They can remember up to almost 80 different scents. So these are very clever animals when it comes to scent. So you have to understand the psychology of the dog in order to train them effectively. The other thing that we did, which is different from what other groups have done, is we were interested in identifying COVID in people that were early stage of infection, that weren't particularly ill, and certainly not hospital patients, because their odors would be might well be very different because of all the inflammatory cascade that occurs when you're very sick. No, we wanted the mild ones, and we wanted people that are asymptomatic, because these are the people that we want to be able to detect at places like airports, or where people gather together in large numbers. So we had a massive drive to do this. And of course, what did we find? By the time we got through and got government funding for this, we were in the summer, low numbers. So it took us a long time to accumulate the numbers that we needed. So how do we collect our odors? Well, we had no idea what's going to work, what's going to be the best way to do this. So we thought nylon socks works. So we're going to do this, collect nylon socks from people, as we did with the malaria cases. Face masks, so we know this is a respiratory disease, the virus is in the lungs, it attacks the lungs. Let's ask people to wear face masks for several hours. And shirts, why shirts? Because the virus probably comes, well, I think there is evidence for the virus to come out in the shirts. And in our later experiments, we don't want the dogs to identify small samples. We want to get them to identify whole people, and that's different. So all the training that one does with dogs is small step-by-step processes. We also wanted to identify the chemicals. Were there any chemicals that are associated with COVID? And to do that, we did some sophisticated analytical techniques using gas chromatography and organic semiconductors as well to pick out particular volatiles. So these are small molecules that come off people. But we're going blind here. We don't know whether these exist or not. So this is really discovery science. Okay, so we had to go through lots of ethics committees, and we had wonderful people that helped us at NHS hospitals, and we had even more wonderful people that participated in our study. And if there are any folk listening tonight, thank you very much for your help. We really appreciate it. This is all your hard efforts, and particularly if you were feeling poorly at the time. Now, what we did here is this shows us the results of the chemical analysis. This is called principal component analysis. And what it does is it reduces the complex data sets. So when you look at the chemicals that come off people's socks, which is what we're doing here, you get lots of traces, lots of molecules. Some are large, some are small, and this system allows you to reduce that complexity to its basic components. And what you can see here is a whole gaggle of red dots to the left and a whole gaggle of green dots to the right. And you know, I've never seen such clear separation. What it's showing us, the red dots are from people with COVID, and the green dots are those without. So there's a very clear difference in the odor profile in the two groups. So result number one, there is a COVID smell, and here it is. And this transitions it from black magic into science. Because people don't think dogs, it's a bit like Ovaltine, you either like them or hate them. But this is the science behind it to show there is a COVID smell. Can the dogs detect it? So we went back to the use of stands, and funnily enough, it was the socks that they worked best with. They could detect a scent on the socks much better than they could a face mask. But we had a training set of samples, hundreds of samples, and we had a test set. So 200 positives, 200 negatives. And I can tell you this, that it's a nerve-wracking experience for the handler to go in blind to do this. And the dogs pick that up. They're not sure that, oh, something's changed, because the dogs are what we call neophiles. Neo meaning new, philes, love. They recognize change and differences to perfection. And when you go, if the handler is nervous, they'll pick that up and they won't perform so well. And interestingly, the specificity actually increased as they went on during the testing. So how well did they do? Well, let me give you a demonstration of these. This is one of our dogs working actually on looking for COVID samples. Instant hit. So this one sits down rather than stands and wags its tail. It's just the dog. And she gets a reward for doing that. So this is the system that we operated. And then we go again. And you can just make out the glass vials there with a small piece of sock about the size of a 50p piece, which has been stored for 6 to 8 weeks. I mean, it's quite extraordinary what these animals can do. Okay, and then we go. Right, so how well did they perform overall? So you remember the sensitivity is the number of positives correctly identified. So it varies with dog, birds, compared against PCR. Now, we did an analysis, and if there are any statisticians here, we use Bayesian statistics to say, well, what happens if PCR is not perfect? And we know it isn't perfect, then these numbers are increase. And these are, so these are the results of that. And then specificity, also pretty good. But if you look at KIP, you see the specificity is not so good. So KIP, if she worked in the real world, would be picking up a lot of people that didn't have the COVID incorrectly. But that's fine, because we know that not all dogs are up to it. So we would test them beforehand and only use the dogs that were really good at it. So like Tala here, 94% sensitivity, 92% specificity, really good. So, okay, so this is a complex graph. So, but let me just go with it. So we'll look at the graph which says dogs, first of all. What this is showing is the sensitivity. So how good are they at picking up COVID? Against the cycle threshold, which is something which comes from PCR. And essentially, the more cycles in PCR, it means there's less virus there. What this is telling us is that the dogs are really good at identifying COVID patients, irrespective of the viral load. So they pick up low viral loads as well as high viral loads. And it's the low viral loads of people that are asymptomatic and those that are just about are becoming ill. So they've just picked up the infection. Compare that with the lateral flow test, which is one on the right, which is pretty good at picking up high viral titers, but it's really poor at picking up low viral titers. So so the end result is our dogs are better than the lateral flow test at picking up COVID cases. So that was a huge thrill and a huge surprise, especially to the mathematical modelers that we worked with, who don't expect that sort of thing. So, okay, so what's this going to look like in the real world? Or to put it more simply, so what? What are you going to do with this? Well, where we want to go, we see that the dogs being used most profitably is at airports, ports of entries. And we have actually been getting our dogs used to working in airport environments. But I want to take you through with this schematic on the right. Here's a plane load of people arriving. So these are 300 people that just got back from Portugal. 3 of them out of the 300 are infected. 2 dogs with the handlers can go through this 300 passengers in 30 minutes. That's the time it takes to deplane, that awful word. Is it a word? Anyhow, it takes 30 minutes to get 300 passengers off a plane. So as they're coming out, the dogs can go past them and identify those people. Almost all the positives. They're going to make some mistakes. You remember, they're not perfect. So we reckon from our understanding of where we are at the moment is that 12% of those passengers will be asked to have a PCR to confirm the dogs. So we see our dogs as a rapid screening technique, which we follow up with PCR, which is still the gold standard. Some people will be inconvenienced that were not infected, but the dogs identified them as being infected. But 88% of the people can go on their way and go home. There is nothing that can touch it for speed. The dogs are really rapid. If you did a lateral flow test on the 300 passengers coming off, you need large numbers of staff, big time delays. So that's what our interest in is for dogs, is in those sort of real world environments. So we're thinking of using them at airports, other travel hubs, could be used for cruise liners, theaters, cinemas, concerts, sporting events. That needs to be worked out, and we're thinking very hard at the moment about this issue of scaling up. There is no way in the world that our dogs can greet every airplane coming in to the UK airports. But the way dogs are used for explosives and for drugs is for targeting specific flights. And that's what we expect our dogs to be useful for here. So, and of course, there are many other examples of dogs being used at border posts. And there are many dog training agencies, military, border control, and police forces. And it would require about 8 to 10 weeks of training to get a sniffer dog up to speed. Although if we can actually make the COVID smell, we could rapidly transform that time and really shorten it. And then just to give you an illustration of where we are here, you remember I said earlier we collected odor samples from people. One of the things we collected was shirts. Well, what we've got here is a demonstration where one person is wearing a shirt from someone that had COVID, and the others are wearing shirts from uninfected people. And this is what it looks like in practice. So this could be at the airport. And the dog gets it right. So that's the training process that we're using at the moment. And it's a slow process to go from the sock to that. We had to dress the mannequins up with the shirts. We had to take the mannequins out of the car park. We had to, lots of stages before we get to this. So it's a slow process, but that's where our vision is, of using this on real people, where we think the odor profiles will be bigger and perhaps even easier for the dogs to identify. And we go, so the conclusion is, one, we showed that COVID has a distinct odor. The dogs can detect it with incredible speed. I mean, it's within a second or two. You saw that yourselves from those images. But our dream is to be able to scale this up, to use the dogs at airports and other venues and workplaces. So in my acknowledgements, before I open it up for questions, this is the part of the team. I said there were, well, over 50 people that were involved with this. This was a big study, very complex to organize. And particularly to thank anyone who's watching that donated samples. Thank you very, very much. And if you're from the NHS and you helped collect those samples, a big thank you to you as well. So, and thank you to the audience for listening, if you're still there.
Thank you, Steve. That was extremely interesting. Yeah. We have had some questions come through. So if you're happy, I'm more than happy to start posing them to you, if that's okay.
Yeah, please do. Go ahead. So
first one we had was, I mean, it's quite a specific one, but we had, how long does it take to train a dog and at what age? I have a hearing dog. Could he be trained to detect COVID-19? If so, how much would it cost and what would the next steps be?
Oh, that's lots of, great that you've got a hearing dog. It might well be, I don't know the answer to the question of whether you could turn it into a sniffer dog, but it depends on the character of the dog. So what you want is a dog that's absolutely determined to do some activity. So the sort of dog that you can throw a ball for 50 times and it keeps on wanting to throw to get the ball, that's the sort of dog that we need. So it's a certain type of characteristic. Interestingly, for the experiments in the lab, you want a more studious dog that thinks about it. Whereas if you're working in the real world, you need a dog which is full of confidence and not worried about anything. And we have working labs or working dogs, which, as I said earlier, are good with their sense of smell. They use their smell, but also because they're nice, friendly dogs. You know, we don't want to frighten people. There are a lot of people out there that don't like dogs. Quite rightly, they know this. They're smelly and dirty. So you don't want any dog which goes by the name of Titan or Satan, or we don't want aggressive dogs. So we have nice, friendly dogs. And indeed, all the dogs that we have are pets. So they don't live in kennels. They live out in family homes, and they're well loved and it's our major concern is about the health and well-being of our dogs. And then they come in 2 or 3 times a week to train. So training depends on the experience of the dog, but to take one from scratch, you want a reasonably mature dog, so presumably over a year old, and 6 to 8 weeks would be very rapid. But it depends more on having the right dog for the task, and the dog handlers are brilliant at dog selecting from the off. So I mentioned that 2 of the dogs are rescue dogs. Well, why were they rescue dogs? Because they kept on wanting to do something, and for normal families, they couldn't handle a dog that was so driven and so bright, actually. But that's just the sort of dog that we want for this. I hope that
Thank you.
Answers the question.
No, that's great. Thank you. Just to dive into the next one then. I mean, this is a really interesting one, and I'm sure might be something you guys are considering at the moment, no doubt. Someone asked, do the findings generalize across variants currently known and potential future variants?
Okay, good question. So when we started collecting our odor samples, this was in the original variant of COVID that came into the country. In November, December last year, when we're ending the collection, the Kent variant came in, which is what the alpha variant now. So when we tested our dogs, we didn't know at the time, but we went back and got the details. 9 of the samples that the dogs saw in testing were the Kent variant. So they hadn't been trained on the Kent variant, but they picked it up during testing. So that was good news. And so what's it like? What would happen to the Delta variant, the variant that originated in India? Would they be able to pick that up? I don't know the answer to that. But if they couldn't, it would take a few days, literally a few days, to just tweak the dogs so that they would be able to pick it up. And I think that's really quick. So it doesn't invalidate it. And one of the other things that we did with our samples, which is different from other dog groups, is in the uninfected people, the people that didn't have COVID, we did take on board those that had other respiratory complaints. So because you could say, well, is it just COVID or is it other respiratory viruses? Because we want to use these dogs in the real world. We don't want the dogs to stop at everyone that's coughing with the common cold, for example. But at least as far as we know now, the dogs are just ignoring those other odors and just picking up COVID.
Thank you. That's really interesting. So if we go to the next one, we had, are there any other mammals that could be used for similar purposes?
Yeah, so there's a group that worked with these very large rats called, I think, Gambian pouch rats, which are huge rats. And I saw them work in Cambodia doing mine detection work. That sounds strange, but they're really good at detecting mines. So they've been used in Cambodia and in Mozambique. And rats also have a great sense of smell and could be trained to do that. And they've also used the same rats, for detecting TB in samples. TB is very difficult to diagnose, and so they've been using rats in some settings to pick up TB sputum with high sensitivity and specificity. So that's good. But I dare say dogs are probably more acceptable at airports than a large rat.
Of course. If we move on to the next one, we have, Does the specificity, oh gosh, I might pronounce it wrong, specificity.
It's taken me months to say that, Lucas, so don't worry about it.
Just came out, that did. In detection change as the dogs age, and are there differences in the specificity between breeds?
No, again, it depends on the character of the dog. In general, we work with working dogs, but we're picking up particular qualities from the dog. So Claire Guest is really the person you want to talk to, because she's a dog psychologist and done animal behavior, studied that at university. So she has these insights into personalities of the dogs, which are being important. But the issue is, does it vary with age? No. One of the things you've got to do is continuous to test the dogs. So you can't use them for weeks and weeks and weeks, and they're not and there are no COVID patients. So it's exactly the same as with drug dogs or dogs that are used to pick up money. So what you do in those cases is you send people through with drugs, and the dogs pick those up. So you keep on monitoring and checking that the quality is maintained. And so every 6 or so months you would test the dog to make sure that the dogs were as good as they were when they started. So there's an accreditation system with all dogs that are used for detecting smells.
Okay, that's great. That's really interesting, actually. I didn't really think about that, but of course, obviously, it's important to make sure they're still performing as well as they did when they were initially, I guess, allowed to go in. And I guess quite similarly to that, is it possible that the success rate of the dog, so in terms of the specificity and the sensitivity of the dogs, identifying positive cases, is it possible that would improve as they work and I guess serve over time?
Yeah, I think that is the case, and certainly during testing, I asked the statisticians to see whether the dogs improved during training, and although the sensitivity didn't change, I don't know why this was. The specificity improved as they went along. And the other thing, which is, if you have good dog handlers, you can tweak it as well. So we were going for high sensitivity, but we were speaking to people in government. Oh no, we don't want to. We'd rather have higher specificity. And I was thinking, well, surely no, you want to stop people coming into the country with COVID, but no, we don't want to call too many people out that don't have COVID. But you can train the dogs to improve the sensitivity or specificity. And the way it works is that if a dog comes along to a COVID sample, they say, yeah, that's COVID, and that one's negative. But this one, I'm not sure. I'm not sure. Wait a minute. Then you teach that dog either that it's a positive or it's a negative. So those few that they're uncertain about, you can tweak either one way or the other, and then that changes the sensitivity and specificity. That also occurs with any lab test as well. You can tweak it. Do you want it really sensitive or more specific? And it's a seesaw. And look at the LFT. It's not very good in detecting low quantities of virus. So you could probably tweak it so that it was, but then you'd have a lot of false negatives as well.
That's really interesting. I didn't really consider, I guess it's a bit of a balancing act. And I guess it just shows as well that there's some politics involved with this in terms of how government might be prioritizing things, which I guess you as a team may have thought, interestingly, would be a different priority to what they requested. So that's actually a really interesting insight. Thank you for that.
Yeah, working with dogs than with people, I can tell you that.
No doubt. I mean, I can definitely vouch for that as well. Is there a minimum or maximum age for training the dogs? And have you found that the sensitivity decreases with age, or do you suspect it would?
Yeah, I don't know the answer to that, but I would think that smell does deteriorate with age. And I think perhaps the more important thing is not about the dog's security of being able to measure, to detect smells at an old age. But if you want the dog to work, it's hard work, okay? It's energetically expensive for a dog to use its sense of smell. During lockdown, I've trained my dog to find its toy through smell. So I go into the churchyard at St Oswald's, and this strange man is hiding a toy, and the dog goes out and looks for it. The dog is tired, gets tired very rapidly, even though she's an incredibly fit and healthy 2-year-old, because they're taking in so much air and it's concentrating as well. It's tough. So the work experience of an old dog would be less than that of a younger dog.
Thank you. I mean, this is a really interesting question. I think I wouldn't have really thought about this one. Someone asked, how would being vaccinated impact a dog picking up the scent of COVID? That's
a really, really good question. We don't know the answer to that, because when we were collecting our samples, that was sort of pre-mass vaccination. But we've been in contact with probably now over 70 different organizations around the world, because we're not alone. There are lots of people that would like to use dogs. And one border force in particular in Australia showed us some data where the dogs weren't picking up people that were vaccinated with COVID vaccines. But the data haven't been published, and so that's a question mark. But at the moment, it looks as though that the vaccination doesn't interfere. And if it did, it might do it for the first few days after vaccination. But then you say, have you been vaccinated recently? And they say, yeah, 3 days ago. Okay, fine, you can go. Because vaccination can produce a response in some deleterious response in a few individuals, and it's usually mild and lasts a few days but then disappears.
Thank you. Next one as well, if you're happy to move on. I'm kind of storming through these, but it's just they're coming in hot and fast. We've got, what happens if someone has recently had COVID-19, is not currently infected, but for example, wears a piece of clothing they wore during the infection? How long does the smell last on clothing for the dog to detect it post-infection?
We don't know the answer to that, but the dog may well pick up the scent of if they wore that item of clothing when they were sick. I wouldn't like to guess what that might be, but I wouldn't be surprised. Okay.
Sorry, were you going to add something, Steve?
No. I think that's a possibility. That yes, if someone's been sick, they're producing. I mean, we don't know what the smell is due to. That's an interesting thing. Whether it's the actual virus or it's the consequences of having the virus infection and the way that the body responds to that infection. There is some experiment actually from the US where they suggest it might actually be the virus that they're detecting, which is quite extraordinary when consider how small a virus is, but we don't know. Yeah, so our dogs are detecting a scent on clothing. So if someone's had it previously and wears clothing that they had when they were infected, then the dogs would probably indicate.
And this might be a bit more of a, I guess, complex question or more of a detailed question. But someone asked, has any work been done on the actual fingerprint of the smells that the dogs are detecting? Could these be artificially or digitally created to standardize all dogs with the same training set?
Yeah, no, that's what we're trying to do at the moment. So we run our samples through gas chromatography, and then they go on to a mass spectrography. Luca, I'm having the problem with pronouncing it. We've clearly got a virus across the internet that's affected us.
Yeah.
But that will tell us what are the molecules, what are the concentrations, and then we can manufacture that and produce a pseudo odor, and that would be transformative when it comes to training, simplify things enormously, and then you could produce that scent and then try it all over the world. And we're very keen to. There are some groups that think they've done that. We'd be interested in seeing whether that is the case or not.
Thank you. And I think this could be our final question, unless anyone wants to ask any more that they have in the time between now and you answering it, Steve. But someone asked, it was mentioned that the dog's sensitivity did not change with CT value. Presumably, this means the odor profile is not linked to virus quantity in samples. In that case, do we know what it actually is that makes them smell?
No. We got two choices again. It's either the virus or the metabolites from being infected with the virus. You know, the body's response, the breakdown of products of the virus. We don't know, too early. But it's a good question, and it's one that I like answered. As with all science, you open one door and then another one appears.
Thank you. That was interesting. And I mean, I guess just quickly then from me, because I mean, I'm wondering this from you, I guess, talking about these and all these questions coming in and you saying kind of that it's something which is kind of making you curious or you're interested in those questions, kind of I mean, if you can talk about it, what is next for you? Are you hoping to kind of cover some of these questions even more? And obviously as time passes, what you initially set out to research is kind of ever changing. So what kind of is, just as to finish off, what's kind of next for you? What are your hopes? What are your plans? And what's going to proceed forward with the rest of this research?
So the big objective is what's over the horizon. Well, we haven't done this for entertaining ourselves. We want to use the dogs in the real world to help border protection or to help identify people. And this technology could be used in different parts of the world as well. So we could translate that. But that's all a question of whether we can get finance to do that, to scale up, and whether people think this is credible as well. Because as with any new idea, as a scientist, you'll say, just a minute, let's think about that. And you're always critical. You won't take that on board immediately. And there's always a battle with the health profession when it comes to using dogs as a diagnostic. I mean, in some ways, it'd be easier if you put the dog in an aluminium box with diodes on it and they'd be happy with that. But because it's a dog, people have assumptions, pre-made, assumptions made which are not correct, actually, about how the dogs work. The dogs are extraordinarily good at what they do, and they have a remarkable sense of smell. And we've shown highly accurate.
Okay, thank you so much, Steve. I think it's great we've been able to cover every question, so that's really great for the participants. So I'll just now hand over to Dave to provide kind of closing remarks.
Yeah, okay, well, thanks everybody. I just want to thank the home team first. I want to thank Luca as our Dimensions scholar this evening for running the event, also Vicky and Liz Ryder for setting it up. It went fairly seamlessly, actually. I want to thank the audience, and I want to thank all of you that have participated in this really fascinating discussion. I think we've all learned so much this evening from this. I want to thank our speaker especially. Steve, the lecture was absolutely inspirational. I was quite interested to see the science behind it, which I hadn't really understood before, and also to see a bit of multivariate analysis that was probably the most convincing and the most robust I've ever seen in my whole career. And it was really very clear what's going on there. I think also the other thing that you brought into sharp focus is just how much of your career has been spent saving lives, which is a really marvelous thing to do. But you've also built up a fantastic H-index as well, which I'm very jealous of. So my final comment is really, as a dog owner, I think we just have to say that dogs are man's best friend. And on that, I'll thank everybody again, and have a great evening. Thank you.
Everyone, thank you, Dave. Thanks, Luca and Vic, and thanks for everyone for listening.
Yeah.